What's going on, Gateway? It's Mr. Bass right here. Algebra 2. I think everybody might be looking at this. We got this video. Let's get it. We got three forms of quadratic equations. Hold on. You know I gotta do this song. Got to give the people, get the people what they want. Ooh, that was smooth. I like that. All right, here we go. So y'all get everything down. We have three forms of quadratic equations, all right? So we're really going in deeper into quadratics to get you all ready for what you need. So remember, you can pause. You guys know what to do. Let me stop it. All right, so first is standard form, okay? So standard form is y equals ax plus bx plus c. So for example, y equals 4x squared plus 3x plus 5. All right, you can pause whenever you need to. But you might want to know, well, Mr. Bass, what is this standard form good for? Well, let me tell you. Standard form most clearly shows that the equation is quadratic, and I can clearly see that because I see this nice x squared right in the beginning. And it also gives me the y-intercept, this c term, right? 5 is the y-intercept of this parabola. C, whatever's last here, is going to be your y-intercept. So let's take a look at what that actually means. Let's get here. So if you look back at it, right, we see the 4x squared plus 3x plus 5. We look at here. Here's what the graph of it looks like. You don't have to copy down this graph. I'm just showing you it, okay? I see it's x squared, but look at this. It tells me my y-intercept is 5. I look right here. There's my y-intercept at 0, 5. So that's the piece of information that standard form is the best at getting to me, all right? So let's move on. Let's go to our second form, which is factored form. This one, the generic version is y equals a x minus p, x minus q. So for example, y equals 0.5, x plus 4, x minus 2. This is factored. We should see this. We just did a whole unit on this, right? We see it has two factors right here. Actually, it has three factors. 1, 2, 3 factors, okay? But these factors in parentheses, they are key. So we're thinking, well, what is that good for? All right. So factor form allows me to easily find x-intercepts. Ha. Okay. I can set, this is important. Let me do this right here. Erase this, and let me put a star right here. Boom, boom. I can set each factor equal to 0 and solve it to find the x-intercept. So for example, write this one down. All right. So for example, I could take this factor x plus 4, right? I could set that equal to 0, solve it, x equals negative 4. My x-intercept is negative 4, 0. Okay? Same one for this one. I can find this factor. It's x minus 2. Set that equal to 0. Plus 2, x equals 2. That means my x-intercept is 2, 0. These are my x-intercepts. These two things, negative 4, 0, and 2, 0. And I can see it right here if I just remember, oh, it's like the opposite of this and the opposite of that. I can see it. But now I have to be careful though, and this is why I said you can't just look at it, because look at this one. If I get this factor, I want to find the x-intercept, I still have to set it equal to 0. 2x plus 3 equals 0, minus 3, 2x equals negative 3, divided by 2, x equals negative 3 halves. There's my first x-intercept, negative 3 halves, 0. And then I got to find my second x-intercept, 4x minus 9. I'm going to set that factor equal to 0. Plus 9, 4x equals 9, divide by 4, x equals 9 fourths. So my next x-intercept is 9 fourths, 0. These are my x-intercepts. Okay, and let's go check this one. Let's look at it on Desmos. So let me pull that back up. Boom, boom. Here it is. So here was that second one, 0.5 plus 4 minus 2, right? I should be looking at this and I see, oh, here's my x-intercept at -4, right? It's the opposite of this one. When x is just that, it's the opposite. It's a -4. And here's my other x-intercept at at +2, right? I see -2, so my x-intercept ended up being at +2, 0. And if I look back in my notes, they're the same intercepts that we were just talking about. All right, let's go to our last form, form number 3, vertex form. So the generic version of this is y equals a times x minus h squared plus k. So for example, y equals 2 times x minus 3 squared plus 4. Now, take a crazy guess. What do you think vertex form is good for? I got this. Vertex form is good because it clearly shows the vertex of the parabola within the equation. H and k give me the vertex, right? It's going to be the opposite of h and whatever k is, okay? So in this one, the vertex is going to be 3 at the point 3, 4, because I take the opposite of this. So it says -3, so the vertex is at +3, 4. That would be the vertex. Let's look at that in Desmos and see if it worked. So I'm looking at this one, and it's telling me, okay, I should be at a vertex of 3 and 4. Oh, look at that. There's my vertex, right at 3, 4. So just want to make sure that you see it and it makes sense to you. All right, so moving on. Now we're going to convert between factored and vertex form, and we're going to convert those into standard form. And we're pretty much just going to do this by doing a couple problems, and do it the same way. We're going to and please make sure you write this down, follow the order of operations to simplify, and then we're going to use the area model to support with multiplication. So if I follow the order of operations, parentheses, nothing to do inside the parentheses, exponents, no exponents, multiplying. This and this are being multiplied, so I'm going to use the area model to support. X minus 7, x minus 9, x squared, -9x, -7x, 63. This ultimately becomes x squared minus 16x plus 63. And look at that. That is standard form. So we're really just multiplying things through. We can do the same thing here. We're going to follow the order of operations. Parentheses, there's nothing to do inside either of these parentheses. Exponents, there are no exponents. Multiplying and dividing, okay? I can multiply. 2 times x is 2x. 2 times 5 is 10. So I end up with 2x plus 10 times 4x minus 6. And now I'm going to use, oh, I don't like that. Now I'm just going to use the area model to support this. So, boom, 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 boom. 2x, 10, 4x minus 6, 8x squared, -12x, 40x, -60. Right? Let me just move this down a tad. When all this is said and done, I end up with 8x squared. Put those together, it's minus 28x, plus 28x minus 60. There is my standard form. I can do almost the exact same thing with this next one. Parentheses, nothing to do inside parentheses. Exponents, there's an exponent. So I gotta use my area model to support me. Boom, boom, x minus 6 times x minus 6, because that's what x minus 6 squared means. X squared minus 6x minus 6x, 36. X squared minus 12x plus 36 plus 7 gets me x squared minus 12x plus, what's that, 43. Boom, boom. There we go. And last one says y equals negative 4, x plus 3 squared minus 9. Same thing, let me follow the order. Parentheses, nothing to do inside parentheses. Exponents, yes. This means x plus 3 times x plus 3, x squared, 3x, 3x, 9. So this becomes x squared plus 6x plus 9 minus 9. This was in parentheses. This was multiplied by negative 4. Now I got to distribute this thing through. This becomes negative 4x squared minus 20 minus 24. Ooh, this doesn't like me right now. Let me try this again. Negative 4x squared minus 24x minus 36 minus 9. And finally, I gotta do that, which gives me the final answer of negative 4x squared minus 24x minus, what's that, 45? Minus 45. All right, there's my video on the 3 different forms and how to convert. First one, let's get it done. Let's do the assignments. Good luck, you guys.